Hello, my name is Ondrej Mirtes. I'm from Prague, Czech Republic, and today I would like to show you how you can perform migrations and deployments without any downtime, so you don't have to show this icon on your website anymore. And my experience comes mainly from working on big Czech e-commerce website called Slevomat, where we have over 300,000 daily visitors, and we are deploying between 10 and 30 times a day without any downtime. My talk will not be about any specific tools, but it will be only about fundamentals. So you can make informed decisions and choose the right tool for the job when the time comes. And my tips and workflows don't require any big changes to the code. So when you come back to work on Monday, you can start immediately benefiting from the things I will tell you today. But I would like to start with a question: why? Why should we care about migrations and deployments without any downtime? Well, sure, if you are deploying only once or twice every 2 weeks, you can survive an hour without, or your customers can survive an hour without your website. But I would like to persuade you that you should deploy more often. So the number one thing I recommend companies is that they should focus more on quick feedback, because you can really benefit from finding out as soon as possible whether a proposed solution works. And I mean both technically and from user's point of view. So the sooner you know that you are on the right track, the sooner you can change things in the right direction or keep going. So who heard this in their lifetime? A lot of people. So from time to time, it happens that someone comes up with this idea: let's rewrite it. And it might be because of technical debt, it might be because of bad decisions, or just that because some more modern technologies are available. Or maybe some new team takes over a project and they don't understand the current solution and they want to create a new one. But the current solution needs to be respected because it works and it makes money. And closing the gap between the old solution and the new one can take years, and you still have to maintain the old one meanwhile. And the result is not certain, because it's not sure that you will end up with something better, because you are developing it on the side and it lacks feedback. And once you are finished with the new version, it might no longer be relevant to business, because the business might have moved on and the business needs changed. So why am I even talking about this? Because complete rewrite is just one possible point on a scale of different approaches. On the left side, in the red, we have complete rewrite, and on the right side, in green, we have work reaching production the same day that you write your code. So most of us are somewhere in the middle. We are repeating the same mistakes, even if we are not rewriting our software from scratch, because we are not seeking feedback, and we are developing it on the side, and the work takes days, weeks, or sometimes even months. And meanwhile, we are neglecting the version in production, and the needs of our users are not satisfied. So we might end up throwing our code away, and in better case, we might end up with huge merge conflicts that are hard to solve. And once we deliver our solution, it might be full of bugs, and the customers realizes that they need something different, and the priorities might have changed. So the longer you are going without feedback, the worse is collision with reality, because you are getting further from real requirements. So if you release all your work at once, it will probably require downtime, and there will be a lot of changes released at once, and it will be surprise for users, and the software might not work in some cases. And also, because of your big release, the whole company stops, because the users need to adapt, and they are very busy reporting bugs back to you. So I'm all for advocating smaller releases, because they are easier to work with, and it's also easier to find bugs in them. So the ideal workflow should look instead something like this. You should deploy new versions more often, and once you increase the frequency of your releases, the quality of your software also suddenly increases, and you are able to fix bugs faster. And your software suddenly starts meeting users' needs, and they are responding to you with feedback, and you are building on that feedback many times a week. And from my experience, the most precious feedback is from production. Because if you put your users in front of test versions with test data, the testing is not taken seriously. Because they might click through your application and they might know that everything's okay, but they start using it for real once it's in production, and they start taking it seriously there. And once it's in production, they start finding real issues, even if they like the version in testing. Another reason not to have downtimes is money. Because if you are running some local service in a single time zone, you might find a time with a minimal impact, probably somewhere around midnight. But there is still negative impact. And it's not possible to find such a downtime window if you are running a global service across multiple time zones. So I don't recommend downtimes at all, because they will still get noticed. And deploying more often should mean that you are having more downtimes. Also, downtimes are risky, because when you are performing a downtime, you have to stay up, sometimes all night, and you are going to be sleepy, and you are going to make mistakes. So, also because you are not doing it probably very often, maybe once a month or something like that, the process isn't battle tested. It's more likely that something will go wrong. So, I have a real story for you. A few years ago, we set out to improve our downtime process. We wanted to make sure that nothing changes the database. So we disabled all entrances to the application. So we put a maintenance page in index.php with an estimated time to go back up. And we also modified our CLI.php that serves as an entrance for Symfony console, so that it immediately exits, so that it doesn't touch the database. But we didn't realize that CLI.php also handled parts of our deployment, so we weren't able to deploy new version under maintenance, which was a problem. So the lesson is the best downtime is no downtime, which is actually what we should have optimized for, not how to make the downtime better. So going into maintenance mode is a little bit like going through the dark side of the moon. No one can help you there. The communications are cut off, and there's a lot of pressure put on you to come back online. So that's why you should be able to deploy and maintain your application without any downtime. So I'm going through the main topic of database migrations. So when you are working on some feature or change, you need to modify the underlying database schema, usually. The first approach that comes to mind is to synchronize migrations and deployments, which would work in an ideal world. But because we are not in an ideal world, we have to do something different, because this is not possible. The migration and deployment have different life cycle. It takes different amount to do each, and it's not possible to synchronize it without any downtime, because the deployment usually is always successful. There's nothing that can go wrong. But the migration can take different time to complete, and it might also sometimes fail and log something. So this is not a viable approach. Instead, we should strive to decouple migration and deployment, make them independent, because if we do this, the old version of the application must still work with the new database schema. So the migrations should be done backwards compatible, and because we must be able to kill the migration and try it again more often rather than the deployment. And also, this is a very safe approach, because if there's a bug in the new version of the application, you can roll back to the old one without any problem. So you can revert back, and because the migration is backwards compatible, it still works. And this is also because you usually don't need migration rollbacks. You can always go forward with the database, because each step you take is small and safe, and there's usually no risk involved. So now I will go through the most common scenarios, how to do backwards compatible migrations. And it's important to split the migration into multiple small steps. So you should already think about database migrations during the development of the feature. And you should also be able to split your work into multiple stages, and each stage should be deployed separately. So usually when I'm working on a ticket or some feature, the finished work usually consists of multiple pull requests, because I'm doing it in several steps. I'm not doing it all at once. And we're also doing each step of the migration while thinking about the application, because the application must be kept working during the whole process. So that's why no migration step carries any risk, and there's little probability that something will break. So this is how you add a new column. First, you add a nullable column, optional one, and this is how we usually do that. So the last two lines, the algorithm in place and lock none, make sure that nothing gets locked, or the database engine refuses to do the alter if it's not possible to do in a non-locking state. This works in MySQL 5.6 and also later with InnoDB engine. And this approach always works no matter how big the altered table is. It might take longer, it might take several hours, but the database isn't locked at any point, so it's safe. And different database engines, different database engines, like for example Postgres, supposedly don't have any problems like this. So you can also do non-locking alters with them. Okay, so this is how our table looks like at the beginning. And we add a nullable column. So this is how our table looks like after the first step. Next, we deploy new version of the application that can write to the column. So the new inserted rows already have the value in the column filled. So for example, here the users started to filling out their gender during the sign up. Next, we can run migration that fills in past data. So this step makes sure that all rows will have the value at the end. So the migration can be either an SQL query or it can be a PHP script. It depends on what you like the best. So we go from this to this. We maybe could have guessed the gender based on the first name, or maybe we can have a third value unknown or something like that. And the migration, in case of big tables, must be done in batches, so that the table isn't locked. And so you don't do a single update, but you probably do an update for 1,000 rows, and then you repeat it. Or you can write a PHP script that does each row separately. Next, we can make the column non-nullable, and now all of the rows have the value filled, and we make it required. And next, we can deploy new version of the application that reads the column. Okay, hooray, we are finished. So there's a little bit of paradox. In order to have zero downtime negations, we have to deploy more often. So, and also when you are doing, it's important to realize that when you are doing the first step, you don't even have to have the next ones ready. You can develop each step and deploy it immediately, and then you can start thinking about the next steps. So it's important to note that this workflow is not blocking. So if you encounter a problem in a specific step of one feature from one developer, you can continue deploying work from another developer while waiting for the fix, even if you are in the middle of a migration. And you can also deploy unrelated changes to production if the migration is taking many hours. So if you have a bigger team, you are typically in different stages of multiple migrations for different features from different developers at once. So the application is always in movement. It is always migrating something. Okay. Another possible migration is removing a column. So it shouldn't matter to you whether the affected table is small or big, heavy used or marginal. So you should always use these techniques, because even if they are not required in some unused small table in your administration or CMS or something like that, you should use these processes, so you will learn how to do them and how to handle them. Okay, so next one, removing a column. If you realize that you no longer need some column, it's time to remove it. So first, you can make it nullable, you make it optional, and then you deploy up version that stops using it. So there's no select, no insert, no update that mentions the column anymore. And next, you can drop the column. So this is quite easier than adding a new column. Okay. So renaming a column, you can't do that directly because you will break the application. You just can't rename a column because you have an application deployed that uses the old name. So in this case, you have to combine the first and second scenario. So first, you add a column with a new name and you do all these steps that we talked about. And second, you remove the old column with the unwanted name. Another very similar scenario is changing type of a column. Again, you can't do that directly because you would log the table and you would also break the application. So again, you add a new column with the new name, with the new type, and you go through all these steps of adding a column, and next you remove the old column. So the drawback of this process is that you will end up with a column of a different name, and since you only wanted to change the type, this is an unwanted consequence. So you can repeat the process to end up with the original name and a new type, but I usually find it unnecessary because I'm happy with the new name of the column. Okay, next, creating a table. This is the easiest. There are no repercussions to the application. You can just do it. And this is also how you can safely extend your database schema if you are stuck with older MySQL or you can't perform non-locking alters on big tables. And I actually recommend creating new tables instead of adding new columns to existing tables that you will intend to be always nullable. So let's say we have a table that combines anonymous and registered users in one place. And we want to add a column or multiple columns that apply only to registered users. So if we want, for example, users to fill email and a city, and registered users must have both an email and a city. So if we add them to the origin table, and we make them nullable because we must, because there are also some anonymous users, then we can encounter a problem because only some nullable combinations of the data are valid. The user can either have both values filled or no values filled, but the design of the table, of the database, also allows us to insert invalid rows. So better solution to this is to create a separate table that serves only registered users, and all the columns are actually required. But only some users from the first table actually have inserted a row in the second table. So only the registered users, and there is actually no way to insert an invalid row in this design. So it's better. So next, until now I talk about databases, but you can apply the same principles to other client-server relationships, because application and database is just a usual client-server relationship. So who uses Elasticsearch? Okay, you also might struggle with downtimes, but you can use the same steps to change the indexes and stay online the whole time. So for example, if you want to add a new key, you can update mapping of the index of the document with the new key. You can deploy new application version that writes to the new key. Then you can reindex all documents, and when they are reindexed, you can start using the new key, for example, in filters or in sorting. Another scenario is when you are upgrading to a new version of Elasticsearch. They are sometimes not very compatible, and you have to create a new server. So how you can do that without any downtime? You can create a new server, new node with the new Elasticsearch version. Then you modify your application so that it writes your documents into both places. Then you write all past documents to the new node so that the new node has complete data. And between steps 3 and 4, there's actually opportunity to test the application on the new version of Elasticsearch. So this is very seamless and safe upgrade because you can test the application. And when you are sure that the application works with the new version, then you can redirect all traffic to the new node and you stop the old one. And because the most common client-server relationship is between browser and our application, you can also apply the same principles there. So when you are adding a new key to read to use by your clients, you can, in the first step, you can add the new key to the exported JSON or XML or whatever format you are using. Then you can deploy a new client that starts reading the data, and then you wait for all clients to upgrade organically, to wait for all users then when they close and open their browsers, which can take, for example, several days. And when you can stop publishing the old key if you were changing something. So this is how you can update your application continuously without users noticing or forcing them to reload. So this is, for example, what Gmail does. Okay. So that was about migrations, and now we can talk about deployments. So application on the server has a lot of reasons to hang during deployment, and I will tell you how to prevent them all. So first thing I want to tell you is that deployment should be automatized. Deployment should not be a complicated process. It should be just a single step. Press of a button or execution of some bash script. You can use bash itself, or you can use some abstraction for build scripts like makefile or think or end or maven or something like that. And once you have a build script for deployment, you can also use the same technology, the same build script for your builds on your continuous integration server to verify that each of your commit works and isn't broken and can be safely deployed. And automation also gives opportunity to add steps to your deployment that will automatically happen every time, so that you don't have to think about that you shouldn't forget something or like that. And deployment has to be atomic. So in a single moment, you should switch your application so that new requests are being handled by the new version, and there shouldn't be any chance of any inconsistent state on your server. So although I crossed Git, you can of course involve Git in your process, but the website shouldn't be served from the working directory of your repository and updated with Git pull, because that's not atomic. That's not, you can leave your directory in an inconsistent state and the request will fail. So, and also it doesn't give you any opportunity to prepare your application for deployment. So we usually want to prepare our application before there's traffic directed at it, which is not possible if you are serving your document root from your Git repository. And of course, the FTP approach is completely broken. The update can take minutes and it leaves the code inconsistent for a long time. So there's something called blue-green deployment, which is a fundamental way how to do atomic deployments and without any downtimes. So this is actually a theoretical concept. You can imagine a lot of things behind the blue and green rectangles, and they represent identical environments. You should be able to deploy your application in the same way to the blue environment and to the green environment. So those environments can be, for example, Docker containers, it can be whole servers, and the main thing to get from this is that you should, the old version of the application is served from the blue node, and if you are deploying a new version, you should deploy it to the green one, and when the green one is ready, you can start switching traffic to the new one. And if there's something wrong with the green one, you can then switch back to the blue one to roll back to the old version. I will talk about this more in depth. So I have the most experience with atomic deployments on the same file system. I don't have much experience with spinning up whole servers just because I want to do deployment without any downtime. So this is usually how it's done. So we have the production sibling that links to the latest release, and with each deployment we create a new directory and prepare the application as much as possible for the incoming traffic, which means that we can compile the DI container, we can compile template files, we can build CSS and JavaScript, and once our application is ready, then we can switch the symlink to the new directory, to the new version. There's a catch, because by default the symlink path is not resolved. So our PHP code actually sees this, or your autoloader. So if there's a request handled in the middle of your deploy, it might load a different version of your file than intended. Because if some file changed and you are loading the new version, then there might be some removed method or some additional argument required, or etc. And you can remedy this by adding a fast CGI param script file name like this, and that means that the real path is used instead of the symlink. So this is actually atomic, and there's no risk of loading another version of a file than you intended. There's no surprise about what gets loaded. But with this approach, you have one problem. Because of different file paths, the OP cache always caches the whole application again. So the more deployments you do, the faster the op cache is getting full. So one solution is to reload PHP-FPM from time to time. And this is mostly fine, and we did this for many years. But there's a more elegant solution to this, and it's through PHP-FPM pools. So if you really can't afford any freeze-ups, you should set up two PHP-FPM pools, and it works like this. So this is actually, again, the blue-green scenario. So you can imagine that the first pool is green and the other one is blue, and the production is always served from a single pool at once. And the second pool is idle and it's available for reloading, so it can free up used memory. And after another deploy, you can switch them, and the first one is the one to reload. Also, as an extra, as a bonus, once you have two PHP-FPM pools, they can be used for warming up the OP cache. So you can call this function OP cache compile file, but it has to be done through a web request, because the command line does not share memory with the FPM pool. So why do we even need warming up a cache? Because this is one of the main reasons why the server can struggle with the new application version. Because some file that we ask for, some generated file, doesn't exist yet it will be generated multiple times. And the duplicate effort by the server can clog up its resources. And this applies not only to OP cache, but also to generating code like templates and fetching data from the database. So that's why you need warming up the OP cache. And some more notes about handling data caching. So the common mistakes developers do is that they clear the cache with each deploy. But that's not necessary. If nothing related changes in the application, you don't have to clear the cache, it can be reused. So don't clear the cache if you don't need to with each version. And similarly to database migration, if you need to clear the cache, you can't synchronize cleaning the cache with the deploy because it's really hard to catch the same moment to clear the cache. So if, for example, your HTML template changes or something like that, and you need to refresh the cache with the new version, you can do it like this. So you can actually change the key of the cache. You can append v2, v3, v4, and this forces the cache to be reloaded when the new version is deployed, because the new cache key is empty and the fresh data are loaded. And some of you might have realized that there's also the concurrent data fetching problem. So the same problem is the same problem as this, basically. But so if you need to prevent this, you don't have to wait for the cache to expire. You can actually pre-populate the cache with some background process, with some cron or something. But this is, from my experience, this is only needed for pages under really heavy load, for example, like homepage. It's usually fine to let the cache expire, so you don't have to solve everything with this approach. Okay. So it's important to know about everything that happens in your application. So you should log every error. You should use something like Papertrail or Sentry that gathers all your logs from your servers. And it's not enough to log your errors in your PHP application, because your server sometimes can return HTTP 502 or 504, which means that the request didn't even reach PHP. So if you don't log these HTTP codes, you don't know about a lot of possible errors that your users see in your application. And this is very common during deployments because of some OP cache related issues and higher load. So you should set up logging of these situations in your web server, if it's Apache or Nginx. Okay, so you don't have to follow all of the advice at once. You can start with some basic points, and if the application and your users demand it, you can improve your setup. Okay, that's all from me today. You can contact me on Twitter or by email and let me know if you need any help with this area.